in this class. Now I am going to explain limit of a function. So before going to define limit of a function, now I am requesting you to subscribe, like and share my channel so that my classes reaches to many people. Now come to the class. Limit of a function. Right? See here, before going to discuss this limit of a function, let us recall value of the function or range of the function. See here, there is one real valued function mapping from set A to set B. See here, f is a one function mapping from set A to set B. Suppose if you consider a quadratic polynomial function, like let us take x square minus 3x plus 2. It is one quadratic polynomial function. Now it is mapping from A to B. So A is the domain of this function and B is the codomain of this function. Okay, what is this? It is one algebraic function, quadratic polynomial function. So whose domain is set of real numbers. So this f is a mapping from where to where? R to R. Here domain is set of real numbers. Codomain or here codomain is also set of real numbers. Okay, right? Now I want to take a real number 3 here in its domain. If you put x equal to 3 here, what do you get? Value of the polynomial, or you can say it as range. So here 3 square minus 3 into 3 plus 2. Now if you simplify 9 minus 9 plus 2, your result will be 2. This is called value of the polynomial or range of this polynomial. For the domain value 3. Now whereas range is 2. Okay students, but when you go to the limit of this function when x equal to 3, okay, what is the result? I hope you have understood this. Here function is mapping from A to B. So here which function have we taken? Polynomial function, whose domain is set of real numbers. So I took a real number 3. So I substituted x equal to 3. I went for simplification. I got 2. 2 is called what? Range of this function with respect to a domain value 3. But when you go to the limit of this function, limit x approaches to here 3. Now f of x. What is the value of this function when x approaches to 3 means generally what do we do? So limit, okay, x approaches to 3. So here write x square minus 3x plus 2. Now replace this x by 3. So that what do you get? 3 square minus 3 into 3 plus 2. Here also on simplifying you will get 2. Then what is the difference between this 2 and this 2 means? See here exactly x equal to 3 we kept to know domain value, but here x is not exactly 3. Not exactly 3. Then how much x can be? Okay, so actually generally for this function we evaluate the limit value like this. This is the problem. So here in which x equal to 3 I simplified. Here 2 is called what? Not range. There we said 2 is the range of this function when x equal to 3. But here what you have to say this 2? 2 is the functional. Okay. 2 is called what? The limit value of this function when x approaches to 3. What you have to say this 2? 2 is the limit value of this function when x approaches to 3, but not the range. Don't use the word range here. 2 is the limit value of this function when x approaches to 3. Observe that here x is not exactly 3, but there x is exactly 3. Then x not equal to 3 means how much x can be? So now let us see that. See here. Take a number line here. Okay. So here 0. Here you make it 3. Now our x is reaching 3. Okay, very close to 3, but not exactly 3. Very close to 3, but not exactly 3. Very close to 3 means, so that x may approaches 3 from left side of 3, or it can be right side of 3. Okay, x is approaching 3 from where? Either from left side of 3 or right side of 3. If it is approaches to 3 from left side, so x may be 2.9999, very close to 3, but not exactly 3. If x approaches to 3 from right side, then x can be 3.00001 and so on. Very close to 3, but not 3. Very narrow gap will be there between the 3 and x. Okay, but x not equal to 3. Okay, students. So if x is approaching from left side of 3, then 3 is more than x. If x is approaching 3 from right side, so x value is more than the 3. Okay, students. So suppose if you substitute this 2.999 for this x, and if you simplify, this result will be 1.9999, but not exactly 2. Okay. So if you substitute x equal to 3.0001 here your result will be 2.0001, but not exactly 2. If it is increasing function, the given function is increasing function, when you take this x equal 2.999 for this x, your result will be 1.999. And if you take x equal to more than 3, here you will get more than 2. If it is increasing function, observe that. Suppose if it is decreasing function, when you put x value 2.99, so your result will be more than 2. If you take x equal 3.0001, your result will be smaller than 2. If it is decreasing function, but your range, your limit of the function, not 2. Okay, now it is very close to 2. Either it may be from left side of 2 or right side of 2. But usually we write this result as 2. Okay. Limit of this function means when x approaches to 3, this range may reaches to 2. Range may reaches to 2. Either it may be from left side of 2 or right side of 2. Okay. So this is the general meaning of limit of a function. Actually in the mathematics we have infinitely many functions, like inverse functions, logarithmic functions, algebraic functions, trigonometric functions, exponential functions, and compound functions, like many more functions we have. Okay, so to evaluate limit of all those functions, we have various methods. Okay, so in my channel, so in future classes I explain you all those models. Okay, right. But in this class, just now I am trying to explain you only the meaning of limit of a function. Okay, right. See students, limit x is approaching a, but observe that a is a real number, x is any variable. Okay, this is not constant, very close to a. Either it may be from left side of a or right side of a. A is what? Real numbers. Then f of x is equal to L. What is L? L is a limit value of this function when x approaches to a. This function can be any function. Either it may be logarithmic function, exponential function, trigonometric function, algebraic function, inverse function. Okay, whatever it may be. Okay. So when x approaches to a, the range of this function approaches to a, L, but not L. Okay, where L also belongs to real number. You may ask me, sir, what kind of x values it may take means, see here, same like a previous example. This is a number line. So here, take small a. So suppose if x approaching a from left side, so you may, this may be our x. And if x is approaching from right side, so it may be x equal this much. So but this is x, this is a. Between these two some narrow gap is there. How much this narrow gap means? Let it be h. Very close to 0, that h value. But it should be always positive. Then this value will be a minus h on the number line. And this value a plus h on the number line. Okay, students. Yeah, actually this is, what is this? X. What is this? X. Which we are going to substitute for x here. Okay, now this is a on the number line. So we are subtracting very small positive value from a. Means a minus h you will get on this number line, you may get that point over here. So that is x, which we are going to substitute for x in the function. So if x reaching a from right side, so here very close to a but not a, no. So this small quantity we are adding to a, so that we may get here a plus h. So our x may be from here to here. Okay, here some gap is there, no? In this gap our x can take any value, but not exactly a. But not exactly a. Our x may take any value from a minus h to a plus h, but not a. So that delete a from this interval. Open interval of a minus h to a plus h. So in which a must be subtracted. So in the calculus language, we have to call this interval as neighborhood of a. Our x will take which value? Neighborhood of a. Either it may be from left or right. Okay. So this x value, students, so we have to substitute in the place of x in the given function. Okay. Either it may be from left or right. If it is substituted from left side, then it is denoted by limit x approaches to a minus f of x. Okay, students. Now limit. Okay. So now when h is very close to 0, so students, here h approaches to 0, f of a minus h. What I am substituting x equal to? This a minus h. When h is very close to 0, so this x reaches to a. X reaches to a minus h. When h value is decreasing, this x closes to a, no? So that I replace x by a minus h. When h approaches to 0. When h value is approaching 0, as I said to you, h is positive. What is h? Okay, gap between the a and x. A and x. Okay, now students. So when h value is decreases, okay, your x very close to a, no? So that I replace x by a minus h and h approaches to 0. So what do you get? Left hand limit. Left hand limit. Similarly, if you would like to find right hand limit, so that is denoted by the letter a plus. So f of x is equal to limit h approaches to 0, f of a plus h. Now, when h value decreases from right side, this gap, when h is decreases, your x closes to a. Okay? So here, I replaced this x by a plus h. When h approaches to 0, so your a plus h approaches to x. Okay? We use this formula to find left hand limit of this function. We use this formula to find right hand limit of this function. Okay, now students. So, when you can say the limit of this function is existent means whenever this left hand limit is equal to right hand limit. Okay na students, when left hand limit is equal to right hand limit, then you can say that limit of this function is existed. Okay na students, so we follow different methods to evaluate a limit of a function. Okay, so some problems we evaluate limit of a function directly, but in some problems we check like this: left hand limit, right hand limit. If both are equal, then you can say that limit of the function is existed, very close to this L. So suppose here this result may be given very close to L, either it may be from left or right. Even this result is also very close to L, either it may be from left or right, based on the given function, either it may be increasing function or decreasing function. Okay, so both, whenever both a left hand limit and right hand limits are equal, then you can say that limit of the function is existed, then that limit value is equal to L. Okay na students, so I hope you have understood the definition of limit of a function. So in future classes from this calculus, I explain you when the function is when the limit of a function is does not exist. Okay, and all those properties we will discuss in the further classes. Thank you.